Hey guys, so today we are going to be graphing equations in slope-intercept form using word problems. Okay, so this is going to be a little bit more difficult because we're going to have to write our equation given the information in the problem, and it's also going to ask us to interpret our different pieces of our equation. So if we look at the very first one, a swimming pool contains 500 gallons and is being drained at a rate of 50 gallons per hour. Okay, so the very first thing you would want to do is go ahead and write your equation. Okay, so remember writing equations from word problems. Alright, so swimming pool contains 500 gallons. This is what it starts with, so this is the initial value. And initial value is also another way to say your y-intercept. Okay? And it's being drained at a rate of 50 gallons per hour. So at hour 1, it drains 50 gallons. Hour 2, 100. Hour 3, 150. So each time we are multiplying by 50. So this is going to be our slope. Okay? Also, since it's being drained, what happens when you drain something? Right, you take the water out. So since we're taking water out, this tells me that we're going to have a negative slope. Okay? Alright, so if we write our equation, as always, we're going to have y equals, and I'm just going to put it, I'll put it right up here. Y equals, and we would put our slope of 50, and then our x, because we always have our x, and then plus 500 gallons. Alright, who can tell me what I forgot? That's right, we said that it was being drained, so we have to have a negative slope. So this 50 is going to be a negative 50. Okay? Alright, so our very first question asks us, what does the slope represent in this situation? Alright, so our slope represents the gallons per hour that are being drained. Okay, so I'm going to make that a little bit more condensed. So water drained in gallons per hour. All right. And so then, what does our y-intercept represent in this situation? Remember, our y-intercept is our initial value. And a swimming pool contains 500 gallons. So it's the amount of water in the swimming pool at the start. And I'm going to put initially, that way we know it was at the start. Okay? Now, how much water will be left in the pool after 3 hours? Oops. Got a little pocket there. Hold, please. There we go. Alright, sorry guys, this is a new document camera, and it's not quite as... There we go. Alright, so there are 2 ways in order to determine how much water will be left in the pool after 3 hours. The first way that we can do it is to take our equation, which is why I wanted us to write our equation of, let me do it this way, y equals negative 50. And then in for our x, because it says after 3 hours, and our x is per hour, because remember, the 50 is the gallons, the per hour is our x. Because remember, after 1 hour, we lose 50 gallons. 2 hours, 100 gallons. That's why our x is hours. So we could put 3 in for our x, and then plus 500. Okay? And then we could solve it that way. Another way we can do it is to go ahead and graph our equation. So, what do you notice about our graph? Hopefully you said there's no numbers down here or up here, meaning that we have to write our own scale, okay? All right, so on our x-axis, we want to put number of hours. So I'm just going to go ahead and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And don't forget to label hours, okay? And then on your y-axis, now remember, this is our gallons, okay? Because we start at 500 gallons. All right, now, obviously there are not 500 little tick marks here. So we have to change our scale up a bit. So I think what I'm going to do is I am going to go every other tick mark and label it 1, 2, 3, 4, 5. And I'm allowed to do this, okay? Just like you are. And for your title of this scale, you would want to put gallons in hundreds, because this is 100 gallons, 200 gallons, 300, 400, 500 gallons. Okay, so I'm going to try to write it on here, and we'll see if I have enough space. Thank goodness for different colors. That way you can actually see what it's supposed to be. Okay, so it says gallons in hundreds. All right. So now we can graph it, because we start at 500 gallons, remember? So if we start at 500 gallons, then I'm going to go to my gallons in hundreds and go all the way up to 5 and make that little dash mark, okay? Now, our slope is negative 50. So another way to write this is negative 50 over 1, okay? And since this is gallons per hour, you go negative 50 gallons over 1 hour. Okay? Hopefully you guys remember this from 8th grade, because I know you guys did gallons per hour and all that fun stuff. Okay, so since we're going negative 50 gallons, the reason why I left the extra tick mark is so that this would be 50 gallons. This is 100, 150, 200, 250, 300, 350, 400, 450, and 500. That way, we just go down 1 tick mark for negative 50 gallons, okay? So we're going to go down 50 to 450 and to the right 1 hour, which gives us 1 hour, okay? All right, and then we're going to do the same thing. So negative 50 gallons to the right 1 hour, negative 50 gallons to the right 1 hour, negative 50, right 1 hour, negative 50, right 1 hour, negative 50, right 1 hour, and so on and so forth. Okay? Alright, so then we would connect our dots as always. Alright. And this time we do not have to draw arrows because we started at 50 gallons. And right here, what does this point mean? So after 10 hours, how much water is left in the pool? 0. Good. Because you can't have negative amount of water in a pool, right? I mean, you can take out water, but you can't have a negative amount in the pool. So once you get to 10 hours, there's no more water left in the pool, so you don't have to draw arrows. Okay? Alright, so now back to our problem. How much water will be left in the pool after 3 hours? Well, we would just go to 3 hours, and then we would go up and over, and that should be 350. And you should get the exact same amount if you do negative 50 times 3, which should give you negative 150, and then plus 500 will give you 350 gallons. On your word problems, you definitely want to include your units. Okay? Alright. Now, how long will it take for the pool to have 150 gallons? So, if you notice in problem 3, our answer was in gallons, and the information it gave us was in hours. Now, in number 4, the information given is gallons, and we want our answer to be in hours. So this time, we are going to set the 150 equal to our equation. So I'm going to have 150 equal to negative 50x plus 500. okay? And you can solve it just like that, or we can go to our graph, okay? Because this right here is 150 gallons, right? Or 1.5 and 100 gallons and hundreds, okay? So we would just go to this little tick mark, and we would go over to right here, and then down, and that tells us 7 hours. So then, let me move this a little bit. So then X would equal 7 hours. And so that's how long it would take for the pool to have 150 gallons. Okay? Alright, I know this is a lot. But really and truly, the only new thing that we're doing is putting it all together. Okay? Because we have done writing expressions. We've done what our slope represents and what our y-intercept represents. We've also evaluated equations both ways, okay? And we've graphed. So really this is just putting it all together. And I know it's a lot. It's a lot to put together. But we're going to try the next one, okay? Alrighty. So going down to the next one. Our temperature is 55 degrees and is rising at a rate of 5 degrees per hour. Okay, so let's go ahead and write our equation. So temperature outside is 55 degrees. This tells me that my initial value is 55 degrees. And what did we say our initial value also was? That's right, it's also our y-intercept. Okay, so then what's our slope? I hope you said 5 degrees per hour, because that would be correct. So just a little tidbit, or a little hint, anytime it says blank blank per hour, or anything that says per, is going to be your slope, okay? Alright, and then is our slope going to be positive or negative? Well, if we're rising at a rate, if we're rising, we're going to have a positive slope. Okay? Alrighty. So, what does our slope represent in this situation? Well, you should say that it's the rise in temperature per hour. Okay? Because remember, we are rising, in temperature, because degrees is temperature, and it also told us temperature. And then per hour. So if you notice, we basically just said whether or not our slope was positive or negative, and then we gave our y value, which is our temperature, and then our x value, which is our hour. Okay, so that's a good way to think of slope, because remember, our slope is rise over run. So that's our y values over our x values. Okay? Alright, so let's talk about our y-intercept. What's our y-intercept? Right, it's our starting temperature. And I put outside just because in the problem it told us that it was outside. Okay, now what's our temperature going to be after 3 hours? Well, do you guys prefer to graph or to do our equation? Well, Miss Johnson, you haven't done the equation yet. You are absolutely right. So let's go ahead and write our equation and you guys help me. Okay, so what do we always start with? We always start with y equals. And then what's my slope? We said it was 5. What always goes with our slope? An x. And then what was our y-intercept? 55. Good. Okay. So then for number 7, we can do y equals 5 times 3 plus 55. Okay? And this will give us 70 degrees. Alright. And then how long will it take for the temperature outside to be 80 degrees? Well, we can set our equation equal to 80 degrees. So 80 is equal to 5x plus 55. And so you would subtract 55 from both sides to get 25 equals 5x. And then you would divide by 5 to get 5 equals x. Okay? Alright. And we have not graphed because I wanted to show you that you could just do it through that. But because it also wants us to graph, we need to do that. Okay? Alright. So, I always do my